Okay, guys. Let's look at section 9.2 because we stopped at 9.1 last time, right? Okay. Now, you guys, because you are currently high school students and probably since at least 7th grade, you have been trained how to use these calculators. Am I right? Yes. In fact, that is a huge part of when you get ready to take any of those tests that they make you take when you're in public school. You're going to have one of these puppies in your hand. And that means you have been taught a number of things in these calculators that a lot of people don't know how to do. And one of the first things you probably did learn how to do is a linear regression. Am I right? Okay. All right. You may not have called it that, but you're going to recognize it when we talk about it. All that a line of, all that a line of regression does is this. It is the line of best fit because you're trying to find the line that most closely models the data if there is some kind of linear correlation. You know how we looked at the scatter plots last time and we had to decide, did it look like there was a linear correlation? And if there was, would it be positive or would it be negative? And then we talked about whether we thought it was strong or it was weak. So look at these points, ignore the line for a moment and tell me, would you say that this basically has a linear correlation just looking at scatter plot? And would you say it's positive or it's negative? Because these points sort of look a little bit like a line. They're not exactly in a line, but it has the general shape, general trend of a line, and it's moving up as you go from left to right. So we want to come up with the line that will best model this data because it's a wonderful prediction instrument. I mean, think about it for a minute. With businesses, maybe they have tracked sales and they're comparing maybe sales to the number of employees that they need to hire. Or maybe they're comparing their sales to what the economy is doing. And if they notice that if they plot those points, it looks pretty linear, do you think that might give them a way to estimate if our sales are about this much, how many employees should we have? If they're tracking what the sales are compared to how many employees that they had when they had those sales. Absolutely. It gives them a tool to be able to predict things. So what you would need is something called the residual. It's the difference between the observed Y value. So let's say I actually have some data points, some ordered pairs. I would take the Y value that goes with the point that's in my data, and I would compare it to what the Y value is on that line of prediction. Okay, that's called the residual when I take the difference. What I'm going to want to do is to minimize this to be the smallest amount possible. Okay, so in other words, if I'm getting the line of best fit, I'm going to have a line that when I take the difference between the actual points and what I would expect them to be on the line, I'm going to get the smallest value when I add them all up. Now, if you look at these dots, the blue ones are the ones that are the actual points, okay? And then these gray ones are the prediction points that are on the line for those different X values. Just in general, tell me what you notice about some of these blue points. These are all where in relation to the line? Above the line. These are all below the line. Do you remember what happened when we were looking for the deviation before? If we subtracted the actual X value from the mean and we added all those up, what did it always end up being? 0, because some numbers were positive and some were negative. Looks like we've got a similar situation here. So what we're going to have to do is to take the sum of the squares of the residuals because some of those numbers are positive and some are negative when I take the difference. And that's going to be part of what I need for a line of best fit. Now, the equation is y hat equals mx plus b. Now, y equals mx plus b, you all know. What form is that? Slope-intercept form of an equation. What the hat means, that little thing on top, is telling us this is our regression line. We're going to use it for predicting y values. So this is going to be that line of best fit that I come up with, and then I can plug in a value for x to find what I think y should be. So m is slope, b is the y-intercept. Now, if we're working in the calculator, they don't use m for slope. You remember what they use? A. Very good. Y equals ax plus b. Okay. And then once we plug in, we would get the predicted y value. Now, look at our formulas here. Okay, for those of you who were not here Thursday, you missed a lot of fun working with the formula to find that R, which is our correlation coefficient. We'll go back over that in a minute as far as how you find it. Look at this formula to find slope. Somebody remind us, what does the N stand for? The number of points we have in our, number of data points we have in our sample. And then that's what letter again?
Sigma.
Okay, it's our sigma, which means we're going to sum up, and this means we'd have to do what? X times y for every ordered pair, and that's going to go in a new column. After it's in a new column, I'm going to add up all that column, all those values, and multiply it times how many I had. Then I got to sum up the x's, sum up the y's, multiply them together, and that gets subtracted from this. Divided by, look at the denominator. I've got n again times the sum of, this means I would have to do what? What is this symbol right here tell me to do? I'm going to have to first square every x. That means I've got to make a column where all the x's get squared, and then I'll add that up. That's different from this, because what does this tell me to do? Take all the x's added up and then square that number. Okay? That's a big formula. You got to know how to read the symbols and then know how to plug in and put it in your calculator. Now, once you have that, to get the b, which is your y-intercept, you're going to have to take the sum of the y's divided by how many pairs you had minus your slope times the sum of the x's divided by how many pairs you had. That's a lot of work, guys. Okay? That's a lot of work. So here's an interesting point. The mean for your x values and the mean for your y values, your regression line will always pass through that point. So if you know that, that's one point you would know on the line. Okay? So we're going to look at this. This was some data we worked with last time. So I'm going to take you over to the calculator in a second. Now, those of you who had notes, let's see. We are looking at, is this on? Yes, it's on your page of notes, right? In fact, can I borrow that for just a second? Thanks. Okay, so let me go here, just a minute. Okay, so here's what you should be looking at on your notes on 9.2. If you don't have those with you, you can certainly copy down this information. But we had, if you remember, this was data that showed the gross domestic product of the top 10 countries or something compared to their CO2 emissions. All right, and so we did some work with that last class. So we're back to the same information. What they're wanting us to do is to find that line of regression from this data. Now, because some of you were not here last time, and I'm going to give this back to you, we're going to go through the how do you find it mode just to be sure that you understand how to do this. So let me show you. Get out a piece of paper if you do not have the notes. And we're going to put down this table. So we have a column that has our X values, which was 1.6, 3.6, 4.9. You guys got it? 2.9, 2.7, 2.3, 1.6, 1.5. And our Y values were kind of big. Now, if you guys already have this from before, you're able to use the columns you created. For those of you who didn't, you need to make sure you understand how to get the columns you're going to need. And 573.5. Okay. Now, we needed a column where we multiplied the X times the Y's, right? And what happened was this times this was 685.12, and I'm not going to fill all these out. I'm just going to, this is kind of how we started. We needed a column where we were going to square all the X values. And that meant that I took 1.6 and I squared it, and it turned into 2.56. And I took 3.6 and I squared it, and that was 12.96. And then I had to make a column for the Y's and square those. And so when I squared these Y's, I got really big numbers. 183,355.24 was the first one. And if you remember, at the end, we had to sum up each of these columns. Right? Y'all give me some feedback. You remember doing this, right? Yes. Okay. So I'm going to give you guys what those values were just in case you weren't here. Does everybody understand then how you fill out each of these columns? Yes. Okay. So if I add all these together, this is going to be 23.1. If I add my Y's together, I got 5554. Does anybody have the data in front of you? What did we get when we added up the X times Y column? That was 50,573.71. Very good. If I added up my X squared column, I got 67.35, and this one was the big whopper. It was 3,775,842.76. So we got some really big values there. Now, if we're trying to find the line of best fit, that regression line for this data, this is our equation, and we have to find the slope, and we have to find the y-intercept. So I want to show you, as far as plugging in, how this works. My slope is this formula, n times the sum of x times y minus, and then we'll multiply the sum of x times the sum of y for the numerator, over n times the sum of x squared minus sum of x, and then square that, okay? So let's just calculate this part first. Count up, how many ordered pairs did we have in the table? There were 10. What did we get for the sum of x times y? That number right there, 15,573.71. Minus, my sum of x's was 23.1. My sum for y was 5554. Okay, does everybody understand where those numbers came from that I just plugged in? Over, my denominator is 10 times, what was the sum of the x squareds? It's this right here, 67.35, right? Minus, and then I take the sum of the x's and I square that. So that's 23.1, and that's going to be squared. Okay, so far you guys with me? Now, you put that in the calculator, and I want you to tell me, plugging into this formula, what you're going to end up getting for M. 196.15. Okay, so we've already had Tiffany worked through it. She's come up with a number. Let's see if the rest of you are coming up with the same number. So what I'm hearing is you've got a positive number, and it's pretty good. I mean, 196 would be a pretty big slope. Let's check and see if you guys get that. Record this. So here's what we're going to do. We're going to put in 10 times, and then I'll type 15573.71 in a parentheses. I'm going to type this just the way the numerator looks. Minus, and then I'm going to multiply 23.1 times 5554, close that parentheses, and I'm going to hit enter because now I'm done with my numerator. And if you want to write that number down, come back to it later, you can. It's 27,439.7. I need to take that, and if I hit the division sign, zoom out just a little bit more, and if I hit the division sign where right here where it's divided by, it'll automatically keep all those digits. But what should I press next? I would make sure I hit the open parentheses button because I need to be very clear to this calculator that everything I'm about to type belongs in the denominator. If I don't put it all in one big parentheses, it's going to divide until I get to the minus sign, and then it's going to think, or actually it's going to divide here, and then it's going to think I'm supposed to take that answer and multiply it times this. So I've got to make sure it knows this is the entire denominator. 10, open a new parentheses, type in 67.35, close that parentheses, minus, and then I want to take 23.1 and square it. And now I can close the parentheses to say I'm through with the denominator. And I agree with Tiffany. She's got 196.15. Is that what you guys are getting? Okay, so that means we're okay with calculator entry. So the slope is 196.15. Now, to get the B, remember the equation on that was what? What did it tell us just a minute ago? We needed to take the sum of the y's divided by how many ordered pairs we had minus the slope times the sum of the x's divided by how many ordered pairs we had. Well, the sum of the y's was this, 5554 divided by 10, minus my slope is 196.15, and I'll multiply that times my sum of the x's is 23.1 divided by 10. Okay, see if you can tell me what you would get for B.
102.29.
All right, double check on that. She's getting another pretty good sized number. She says it's like 102 something.
0.29.
Do y'all agree with that? This one's not nearly as messy as the other one, but you still have to be careful with your calculator entry. So make sure you're getting 102.29. If I now write my y hat, that regression equation, how do I put these pieces together? Y hat would equal, come on guys, 196.15 plus, because that's a positive number, 102.29. Agreed? Okay. Now, let me take you back. Yeah, I think it might have been thunder. Yeah.
Because he already ate us.
Okay. So there was our table. Here was our formula. And that's the same equation that they got. Now, let me show you this. Let's go back to the calculator for a second. And I know you guys are going to be very comfortable with this, but just in case, I have somebody who's a little bit iffy on how to put this in. And keep in mind, we're recording this to share with my night class on Wednesday night, and many of them are not high school students who know how to use these calculators. So y'all help explain if I wanted to do this the easy way instead of having to use the nasty formula. And this was the information you were given. What would you do if I told you to get a line of regression?
Put it in the L1 and L2 and then go to line of regression.
Okay, so you would go to Stat, Edit, and your L1 would be your X values. So I'm going to type these in. And then what's going to go in my L2? My Y's. Okay, y'all watch me to be sure I type these in right. Sometimes I hit a key and I don't hit it hard enough. Okay, then my Y's. Okay, so I have everything in there. My 10 ordered pairs. Sure do. Thank you for catching that. That would have been not a good thing. Okay, so I think we're good now.
We're getting
Huh?
My bus driver's, he's not good. He's in his very good.
Your best, oh, as far as driving on wet roads? Okay, well, yeah, we'll all say a quick prayer together before you guys leave. All right. Now, that's in Stat, Edit. If I want that line of regression, tell me what buttons to press.
Stat.
Go back to Stat, but this time, Calc, choose 4. Now, before I do this, remember, if one of the things you needed to find was that R value, your correlation coefficient, let me just back up for a second, because if you don't have this turned on in your calculator, you won't see the R value. So if I want to see the R value, tell me one more time, what buttons do I press for it to show?
Second 0.
Second 0, which gets me in the catalog. Now what? Yeah, since it's already in the alpha mode, I just need to go to the D. This is like my index. So my D button is the X to the -1 key. That jumps me to that part, and I'm going to scroll down until I see diagnostic on. If I hit enter, it's going to blink at me. If I hit enter a second time, it says done. Now it should show up. If you try to do your linear regression and an R value doesn't show up, this is how you fix it. You got to go into diagnostics and turn it on. So now we'll go back to Stat, we'll go to Calc, and you guys said we want a linear regression, which is number 4, correct? Okay, now here's what I'm going to remind you that would be a good idea to do. If you have this kind of operating system, it's kind of nice because it's prompting you to make sure everything is the way you intend for it to be. So it's confirming your X's are in L1, your Y's are in L2. That's where we put them. If I put them in a different place, this would let me change it. If you have an older operating system, then you're going to see the linear regression, AX plus B, and it's going to be blinking after it because it's going to give you the option to tell it, I want you to paste this equation after I run it in my Y equals. Now, you guys told me of a different way. When you get to store regression equation, what were you saying is a good way to get it there?
Alpha trace.
And that's right now, alpha trace?
Yes.
Alpha trace brings up these options, and I can hit enter, and it will type in Y1. If you don't have an operating system that's letting you do that, if you try to do that and it doesn't show up because your operating system is older, you can always hit bars, arrow over to Y bars, and you can find Y1 as number 1 under function. So it's bars, Y bars, and you hit enter about 3 times, okay? And now when I calculate, here is all of my data. We found this R value last time. We knew this had a strong positive linear correlation because of the 0.88 that we saw for the R value. But it also gives me the equation. Is that what we found doing it by hand? It is. So obviously it's a lot faster in the calculator, but it's doable by hand. Now, here's the other thing that's cool when you store it. if you go to Zoom Fit, which is Zoom 0, it will set my window so that I get to see my scatter plot points and I see my line of regression on here. And I've got a few scatter plot points that are missing. So I might need to go back and manually fix my window because my X-Men really ought to start at 0.
Would it work better if you went to the Zoom stat?
Let's try that. If we do Zoom Stat, there we go. Zoom Stat did go ahead and adjust it for us. So now I can see everything and see where the line is in relation to the points. Now, FYI, we're going to take a quiz over 9-1 and 9-2 probably next Tuesday, all right? And one of the things I'm going to do is give you a question a lot like this, where you're going to get some ordered pairs. It won't be a gob of them. 10 is probably pushing it. It may be smaller than that. But I'm going to ask you to draw me the scatter plot. I could ask you to put the line of regression on it. Most likely I won't, but I'll definitely ask you to write the line of regression. Doesn't matter to me if you get it in the calculator or you use the formula. But if you did it in the calculator, what should you write on your sheet so I know how you got it? Stat, calc, and then, yeah, linear regression. Okay, that's my clue that, yes, I did use the calculator. Here's something else that I might ask you for the R value. Again, you could use the formula, compute it by hand, but that's going to mean I should see a table where you found all those values you're going to need. Or you could find it in the calculator if you use one variable stats. Does that make sense? Okay. Now, this just explains how you can do what we just did in the calculator. This was using the data for Old Faithful, though. Now, this is kind of important because you need to be sure when you do get the line of regression, you understand what it's useful for and what it's not, okay? So there is a rule with these linear regression equations. You have to be sure that, first of all, your R value is reasonable to show that there was a linear correlation. If I came up with some sort of line, equation for a line, but my R value was 0.015, that's meaningless. So I need to make sure I've got a pretty strong correlation. But here's the other thing. We need to be sure that the values we want estimates for are within the range of values that the x's that were provided for us. Here's what I mean. If you look back at, give me just a second so I can show you. If you look back at, where is it? There. Okay, if you look back at this data, okay, what do you see as the smallest x value in the list? It's 0.9, okay? What's the largest x value in this list? 4.9. As long as I'm asking you to estimate what the y value is for some number of x that's in between 0.9 and 4.9, my tool is pretty accurate. I use it. But what if I asked you to estimate when the value of x was 15.7? That doesn't fit within the boundary of the data I have. It's possible that it's linear through there, and then it does really weird things when I get past my largest values. So I've got to be sure that I am using valid points for the data that I have. Okay, makes sense? So here's our equation we just came up with, and we're going to predict the expected carbon dioxide emissions for these following GDPs. Now, is 1.2 within our window? It is. Is 2.0 within our window? And is 2.5 within our window? Yes, so all we would have to do to come up with these answers is what? Yeah, plug them in for x. So you're going to take that 196.152, multiply it times 1.2, add 102.2892 to it, and see what you get. That would be your expected carbon dioxide emissions. Yes? If you wanted to actually use some of the calculator features, you could do that. You could. Now, the only thing about second trace is be careful, because sometimes the data or the value you're looking for may not be easily found, but you could do something like this. If you wanted to go to calc and you wanted to put in a value, all I have to do is tell it, I want to know what it is when it's 1.2 for X. It'll give me the Y value there. Okay, so yes, if you want to use the calculator feature to help you, that's not a problem. You can also just plug in by hand, and you're going to get this. If I plug in 2, I'm going to get 494.593. And if I plug in 2.5, I get 592.669. So far, is this pretty easy? Yes? No? Yes. Okay. Now, this is where it tells us those prediction values have to be within the range, or at least close to the range of those X values we were given. So in this case, if we end up with something like 0.2 or 14.5, this equation we have isn't a valid predictor of what to expect. Okay? So we good?